Hello and welcome back to A Slice of Physics. A central part of this course is understanding motion. So let's begin our look at motion by understanding motion diagrams. These are a visually intuitive way of representing motion. And by visually intuitive, I just mean that what you see is what you get. It just makes sense. Essentially, a motion diagram shows successive positions of an object after equal time interval, and it uses the particle model where the object of interest is illustrated as a dot. Let's start with an example of a car that's moving to the left and slowing down as it goes. And let's say somebody is standing at the side of the road as this car moves and takes a snapshot or a picture of it after equal time intervals, let's say every 2 seconds. So here's the first picture they take. 2 seconds later, the car is here. 2 more seconds later, it's moved over to here, and 2 more seconds later, it's moved over to here. If we put all of these pictures and stack them in one view, they would look like this. And you can see that the distance between the car as it moves to the left is decreasing, which is consistent with it slowing down. Now in physics, you will see that drawing pictures is a crucial step in solving problems. However, we care about the information that's captured in the pictures rather than their artistic appeal. So we will show the object of interest, in this case this car, as simply a dot or a particle, and hence we call it the particle model. So the car is here represented as a dot, and then here represented as a dot, and then moves over to here, and then finally to here. And to give these particle representations a sequence of direction, we will put numbers below them that represent the timestamp. 0 is when the time started, 1 is a time interval later, 2 is an equal time interval later, and 3 is an equal time interval later. The crucial thing with motion diagrams is that the time interval between any two successive points can be anything. It can be 2 minutes, it could be 2 hours, 5 days, whatever. The crucial thing though is that once we pick a time interval, it's the same across each of these successive points. So if the time interval here is 2 seconds, as we said in our car example, it has to be 2 seconds between 1 and 2 and between 2 and 3 as well. Once we pick a time interval, it's the same across all successive points on a given motion diagram. So here's our motion diagram for this example that we have been discussing of the car moving to the left and slowing down as it goes. Notice that it captures all of the information that we have talked about, but in a more succinct manner without having the pictures. Let's take another example, one of a ball that's tossed in projectile motion. So when it's tossed up and to the right, it's going to first move like that, up and to the right, and then once it obtains a maximum height, it's going to start moving down and to the right as shown. Now in a motion diagram, rather than the pictures, we prefer a particle representation. So all of these pictures of the ball will be replaced by particle model with the corresponding timestamp as done here. We've got 0 here at the starting point, and then 1, 2, 3, and 4 after equal time intervals. Okay, so far so good. See, I told you that motion diagrams are pretty visually intuitive and they just make sense. To wrap this up, let's take an example of a motion diagram that I'll give you, and then let's see if we can figure out what's happening and extract some useful information from this. So here's a motion diagram. I've got positions at successive time intervals shown here. Can you guess what's happening here? While you may be tempted to come up with an answer right away, we got to first get the sense of direction of motion. So I need the timestamps that we have been talking about. So let me fill those in. 0, 1, 2, 3. So now we can tell that this object is moving down vertically in a straight line. That's number 1. Number 2, we can see that as it moves down, its distance keeps increasing for equal successive intervals of time, which tells us that this object is speeding up as it's falling down. That much information is readily available from this motion diagram. We can now put this together with our common sense and say that this might be an object that's falling under the force of gravity, maybe a stone or a ball that's dropping under the force of gravity. And that would make sense because anything that's falling under gravity will speed up as it comes down, as shown in this motion diagram. So in this slice of physics, we have started our journey about motion. We're going to be spending the next several weeks talking about motion, and we have started that discussion with motion diagrams, which are a visually intuitive way of representing motion. They show successive positions of an object after equal time intervals utilizing the particle model where the object of interest is illustrated as a dot.